Hello everyone, I'm Fariha Jaigirdar, Faculty of Information Technology, Monash University, Australia. Welcome to my presentation for TrustcomC4W 2020. On behalf of other authors, Kirsten Rudolph and Chris Payne, I would like to present my paper today. The title of my paper is Prov-IoT, a security-aware IoT provenance model. So this the contents that I would like to discuss today. At first, I'll give a brief introduction, then I'll discuss about the research gap uh, for this one. Then I'll describe about the ProVIoT model, the proposed model. Then I'll give a brief discussion on the class diagram, and then I'll have a discussion on the IoT health provenance graph, followed with a comparison of my proposed IoT model with other existing models, and then finally I'll conclude my talk. The Internet of Things continues to gain popularity in various sectors. For example, in smart cities, smart transportation, and smart healthcare applications. But the thing is, the amount of data generated from various sensors, actuators, and the smart objects is continuously increasing as well. Well, if we think that okay, we are getting that much of data, but the thing is, this increasing dependence on data is actually generating different kind of security issues. And among these, we can say that one core problem is the propagation, aggregation, and processing of data through many layers of more or less open dynamic systems. So if you just can think about this, this is an IoT health scenario. So for this one, this is really possible. The sensors are in the patient's body, and also the patient can be in a hospital care. So this is representing a sensing layer in IoT health structure, and then in a three-layer structure of an IoT health, the second layer is network and data processing layer. So this data that has been gathered in the sensing layer is actually transferred to the next layer, and then there can be any kind of gateway, and then the cloud who is actually processing and aggregating the data, and then it's transferred to the application layer where a doctor or an auditor or an ambulance service with its automated system is working on the data. The doctor can be giving different kinds of decision, can be give prescription on the data gathered, or can be take any kind of decision on the data he gathered. So in between there are different things involved, right? So how come the doctor actually trusts the data? Because if he is not confirmed that the data integrity is maintained in between all the layers. So the thing is relation between input data, training data, and the resulting classification, the provenance of these various inputs are not obvious to the human users. So in my paper, I actually discussed three questions, which are the issues for secure propagation. And then, with the light of this discussing of these questions, I came up with the ProVIoT model as a solution. So the question comes here that is the right data obtained from the right sensors in the right context? And the second one is the data presented to the end user a correct representation of the original data? And the third one is has the end user any means to check that the data which is he is working with, he is giving any decision on, he is think that it is a one he should work with, it is actually correct or authenticate from the right IoT sensors, and all the processing steps are involved in between. And if we say that more specifically, is the end user able to validate the question one and question two with respect to possible security risks? Well, here comes with thinking about data provenance. Um, so the data provenance is actually measuring and identifying the integrity, authenticity, and availability of data, um, of a complete data chain, which we call it provenance of data. And a data provenance graph is a set of metadata that documents the complete data lineage and the processing records by revealing who, what, when, where of data history, so that the data forgery and manipulation in principle can be detected. Okay, so all the security requirements for each layer induce the need for security controls. The user usually has no or specifically little indication of what security controls have been used in different steps documented in the provenance graph. Therefore, for the overall security of the system involved in a data path, various security controls can be relevant and evidence on their use can potentially contribute to improve trust in data. Okay, so what is the gap in security awareness in provenance-based research? The thing is, there are research which is actually work with securing the provenance graph, the whole provenance graph, but the working with security awareness in a provenance-based research is actually not very common. So current research has investigated the protection of integrity and authenticity of data history in provenance graphs, and there are different examples for that one. However, no studies have investigated the documentation of necessary security metadata at each phase of data propagation. Information on security controls for each propagation step needs to be added to enable the end user to evaluate the risk of data manipulation or any intrusion at each step so that an appropriate system decision can be taken. Therefore, secure provenance also needs to include metadata documenting security controls across the layers. Well, so here I'd like to discuss about my proposed Prov-IoT model. Um, and for this one, we present the Prov-IoT model which track data aggregation and other data processing throughout the propagation, which complies with the provenance data model, which is ProvDM, proposed by W3C. In the ProvDM model, whoever is actually working with the data responsible for generating different kind of data or document is indicated as an agent, and the data or the document itself is indicating in the entity in the ProvDM model, and the processing or generation or modification, different kinds of workflows. These are actually indicated as an activity, and also as you can see, there are different relations involved in the ProvDM model. Well, so in our Prov IoT model, we start with working with the ProvDM model, and then we add some attribute, and as well as the we add the so that all the processing steps are included in the Prov IoT model. So in the proposed model, actors and end users are involved in the overall process representing an IoT environment. Actors are responsible for generating the data, and end users work on those data. Data creation and the modification process can obtain as can contain different kind of workflows executed by one or several kind of agents, as you can see here. So initially the data X is generated, and after potential several workflows, different processing, aggregating and fusion, finally the complete process delivers the data Y to the end user. So it is really possible that a process consists of sequence of different kinds of workflows. So here we include the data subject attribution, which is used to the model to report which subject is attributed to which data. Various data can be aggregated to generate the final process. So as we can see that it is really possible that agent can be any actor or users in the system, and the ith workflow operation we are showing here. We are showing in this one using agents and data xi and data yi involved. And the communication you can see here, the communication is the proposed model represent data transfer from one layer to the next or between different steps within one layer. All right. So the security metadata, it includes evidence on security controls for each process generated from each workflow. Thus, the security metadata along with the data subject attributions should enable end users to validate security properties of a data propagation in the overall system. The level of provenance details needed by actors depends on specific application. Therefore, a granularity policy in the Prov-IoT model limits the detail of provenance information used for validation. And the provenance policy are the basis for data provenance validation by the end user. So these are the information that should be gathered by the Prov-IoT model, and the data provenance validation should be give some kind of validation at the end to the end users. So this is the proposed Prov-IoT model, where we can understand that all stepwise relevant information of data generation, modification, or any kind of changes should be documented along with any kind of security related information, so that at the end the end user who is actually working on the data can get some kind of estimation of the risk involved, and also can get the security analysis and trust or untrust the data. All right. So there are some definition that we actually use in the Prov-IoT model. So as you can see that the security metadata, which are different artifacts representing security evidence at any layer of an IoT architecture. This metadata can include different kinds of evidence on active security controls, can be any kind of security protocols for the communication, any kind of authentication mechanism, security mechanism, evidence on different configuration or particular software running on a device. The Prov-IoT model represents the framework for security-aware data provenance that is used to identify the steps to be documented. So as you can see, this model actually contains different actors, data X, data Y, communication, and so on. All right, so what is the Prov-IoT graph? The Prov-IoT graph is the graphical representation of an instance of the Prov-IoT model. Okay, so now here is the design class diagram for the Prov-IoT model. Well, I'm not going to describe all of the attributes. So, for example, like different attributes, how they should be added, I mean, how they should be linked with one another are actually showing in this Prov IoT class diagram. For example, like if you just think about security metadata, the evidence of the ID using what kind of security mechanism is using, this should be represented on any on with an ID. The actors or the end user involved with their security metadata should be added here, also which, in which domain or the condition involved, and the particular evidence for the security metadata should be involved in the class. Okay, so here we actually demonstrate a hypothetical scenario with a patient and the relevant provenance graph with the proposed provenance model and class diagram for different activities. So here is the proposed provenance graph for that particular health scenario. So with that scenario, we actually describe it in the paper, um, uh, but all the relevant activities and workflows involved, what are the agents or the user and the actors involved in the graph also showing with the entity used in the model. So, for example, like it's starting from patient registration with the capture of data and the data processing and how the data is available to the system. It is really also showing the hospital device access and also the remote device access as well. So the thing is, for to design this data provenance graph, we first follow the ProvDM model of W3C standard provenance graph and then refine this graph based on the proposed Prov-IoT model. All right. So following the Prov-IoT model, adding data subject attribution and security metadata, including evidence of security controls, can document the relevant metadata and the later it can be used for validate if the system satisfy the hospital security policies. As I hope that you can remember, in the Prov-IoT model, we have the different kind of security policies and the granularity policies as well. So if you just analyze some relevant parts of this example scenario to clarify the importance of adding security metadata and why we need to document them and then why we need to validate it further. Okay, so we just consider the part of the graph, maybe the first two activities of the scenario. So the thing is, we consider uh, the part when the first measurement are recorded and also the sensor are captured. The thing is that there are different consideration for this, right? For example, how can we check the layer-wise security vulnerabilities can and assess the relevant risks? For example, during the first activity, John's identity might not be properly linked to the sensor and the malicious user may assign the data to a wrong identity. In the second activity, it is really possible that a malicious user might try to manipulate and the stored and forward sensor data. While the Prov-IoT provenance graph will not guarantee security. This is really important to understand that the proposed Prov-IoT model it will not guarantee the security. But by adding security metadata, it documents security control used at each layer so that the relevant risk can be assessed. So as you can see that For these kind of activities, what kind of protocols are used, what kind of security mechanism metadata has been used, what kind of device has been used, what are the software has been used for this, all have been documented in the probability graph. So it is really possible that that the data has been used, the data that is using or that is propagating from one step to another step. It is actually a plain text. It's not encrypted at all. So with that information, while getting to the end user who is working with that, he can get the uh, j- justification that whether he should work with the data or not, whether the data has been added, has been gathered, are trustworthy or not. So there should be some different different mechanism for that as well. So here we can see that also like what kind of security mechanism has been used along with the key length and all these things. Also, you can see that in this pay phase we have just added that there is unencrypted data. Also, the version of the software can be added as a security metadata. For example, like if you say that, okay, when the VPN has been added in the system, so what kind of what kind of system structure with this VPN will be a secured one or not. So there are many issues involved with this security metadata while we are adding it, and at the end, the user who is working with that can be get a proper security analysis with that one. All right. So here we actually compare the providing model with the existing provenance model. So we compare it with three views: the provenance metadata, security mechanism, and security error model. So in our paper, we have different comparison parameters, and for the security mechanism, for example, we actually think it from two perspectives. The first thing is whether the paper that we are working with in different years, whether they have discussed the security or they are proposing some security method. It is really important to understand, as I already mentioned, that our proposed model is not actually proposing any kind of security method, but it is going to discuss security and give the security awareness in the with the proposed model. With the security aware model, we discuss and we work with data processing and aggregation. All the steps have been involved. The cross-layer dependency of the IoT architecture has been considered. The security metadata, which link different security across layers, and the single point of failure are also considered, so that at any particular point, if there is any malicious activity happen, and at the end it should be documented, so that at the end the user should understand that whether it is the data that he's been working with is trustworthy or not. So the thing is with this comparison, we it actually creating a security aware provenance graph through adding security metadata, and it is the main contribution of the Prov-IoT model to the state of the art in the data provenance. Okay, so this paper actually first discussed relevant challenges from various security attacks on data propagation and pinpoints the importance of adding security metadata to provenance information at each layer of an IoT environment. So this security metadata create an opportunity for systematic data propagation analysis. And in this paper, we introduce a novel IoT provenance model named Prov-IoT with an associated class diagram. So these Prov-IoT documents the history of data records, considering data processing and aggregation along with security metadata that enable the foundation for trust in data. And this one should be beneficial for uncovering any kind of system fault or intrusion, and it should be also useful for decision-based system for security analysis and risk estimation. Okay, so yeah, here I conclude my presentation, and if you have any kind of question or any kind of discussion or any kind of anything that you want to discuss with me, just here is my email address, fariha.jagidar@monash.edu. Just shoot me an email. I'm really happy and very open for discussion, so that anything we can work on for further research. All right, thank you very much.